Good morning, students. In the previous class, we see how to find the given system of equation by using Gaussian elimination method. Now you use the same method to solve some practical problems. Practical problem means some word problem. We solve the word problem using the same method. You see in the exercise, the next one, second one quadratic polynomial is given. If ax square plus bx plus c is divided by x plus 3, x minus 5 and x minus 1. The remainders are 21, 61 and 9. Then the question is find the value of a, b and c. You see the bracket, use a Gaussian elimination method. The method is same, but the given problem in word problem. Now we solve the same problem by using this Gaussian elimination method. First, we will take the name of the quadratic polynomial. Is our choice. Is a quadratic polynomial in terms of x. So I will take it is f of x. Let f of x is equal to ax square plus bx plus c. When this quadratic polynomial is divided by x plus 3, it leaves one remainder. The remainder is 21. So how to write? That is by data. We write it is by data when it is divided by x plus 3. So we put x plus 3 equal to 0. The value of x is minus 3. So when it divided by minus 3, it leaves the remainder is 21. How to write? By data f of plus 3 is there, so minus 3. That value it should be is equal to 21. We write in order the remainders. When our given polynomial is divided by x plus 3, we put x plus 3 is equal to 0. The value of x is minus 3. So f of minus 3 is equal to 21. So how to write the second one? If it is divided by x minus 5, if it is divided by x minus 5, it leaves the remainder is 61. How to write? We put x minus 5 is equal to 0. The value of x is 5. So f of 5, that value should be is equal to 61. The second one, remainder is 61. How to write the third one? Is x minus 1. We put x minus 1 is equal to 0. The value of x is equal to 1. So f of 1. The value of f of 1 it should be is equal to 9. So it is our given data. Now using these data, first we form an equations. In the previous class, directly the equation is given, then to solve by Gaussian elimination method. So in this problem, first we form an equation and then to solve the given equations. So now f of minus 3. We find the value of f of minus 3. We will take the value of f of x as the value of f of x as ax square plus bx plus c. F of x means ax square plus bx plus c. So f of minus 3 means we replace x by minus 3. So in this polynomial, whenever x is there, we replace x by minus 3. So a of minus 3 the whole square, because the value of x is minus 3, plus b of minus 3, plus b of minus 3, plus c. So it is a value of f of minus 3, but f of minus 3 should be is equal to 21. Is equal to 21, all are equal. So I will take only the needed terms. So I leave f of minus 3. So a of minus 3 the whole square is 9. Plus and minus is minus 3b plus c is equal to 21. So we write it is 9a minus 3b plus c is equal to 21. So now we form the first equation. In the system of equation we form the first one. Now we take the second one. Now what is the next one? F of minus 3 value is not 21. Next, f of 5 value is 61. So f of 5. How to find f of 5? In f of x, we replace x by 5, we get f of 5. So now we move f of x value. The value of f of x is ax square plus bx plus c. But we need f of 5. So whenever x is there, we replace x by 5. So f of 5 is equal to a of 5 square plus b of 5 plus c. That value should be is equal to 61. So now we write it is a of the value of 5 square is 25 plus 5b plus c is equal to 61. So 25a 5b plus c is equal to 61. Second one is a frame. Also, one more data is given. What is another data? The value of f of 1 is also 9. Also, f of 1. How to find f of 1? In f of x, we replace x by 1 via f of 1. Now we see the value of f of x. The value of f of x, ax square plus bx plus c. Now we have f of 1. So whenever x is there, we replace x by 1. So f of 1 is equal to a of 1 square plus b of 1 plus c. A of 1 square plus b of 1 plus c. But the value of f of 1 is given. The value of f of 1 is 9. So we write it is a plus b plus c is equal to 9. I shortly write 1 square value is 1. A into 1 is a. B1 b plus c is equal to 9. Now you see we frame 3 equations. In the previous one, there will be 3 equations is given directly. That is allowing unknowns x, y, z. But in the given question, to find the values of the constant a, b, c, all the 3 equations involving in a, b, c. So now we framing the system of 3 equations. The next step, we write the given system of equation in a matrix form. So how to write the matrix form? In matrix, we see the first equation coefficient of a, b, c. The first equation coefficient a, b, c are 9 minus 3, 1. 9 minus 3, 1. Second equation coefficient of a, b, c are 25, 5, 1. Third equation coefficient of a, b, c are just 1. 1, 1, 1. 1, 1, 1. The next one is important here. The variables x, y, z or any other number. It's not x, y, z because all are indicating the letters a, b, c. So we write it is a, b, c. And RHS matrix. The value of the RHS or the first equation. The first equation RHS is 21. Second equation RHS is 61. Third equation RHS is 9. Now we expand, we get the 3 equations. You know the matrix multiplication. 9a minus 3b plus c. It should be is equal to 21. So it is the first equation. 25a plus 5b plus c is equal to 61. Second, a plus b plus c is equal to 9. Third equation. So the first step to framing the equations. The next step to convert the given system of equation in matrix form. Now it is formed. It is of the form Ax is equal to b. It is the first step. The next step, we write the augmented matrix. The next step is the augmented matrix. Another name of augmented is extended. That is, the matrix A is extended by the matrix B. So it's A by B or A over B. First of all, we write the matrix A as it is. Now you see, It is the value of the matrix A. Now the matrix is extended by the another matrix B. So first row 9 minus 3 1. So you write as it is 9 minus 3 1. 9 minus 3 1. You lie 1 bar or should be read it as line. Is extended by B, whose corresponding element of B is 21. So 21. We do the process in the next two rows also. Now you see the second row. 25, 5, 1. It should be extended by the RHS matrix is 61. So the elements contained in the second row is 25, 5, 1, 61. 25, 5, 1, 61. Third row. 1, 1, 1. It should be extended by the another RHS value is 9. So 1, 1, 1 and 9. Now it is the augmented matrix. What is the next step of the augmented matrix? The next step of the augmented matrix is to convert the augmented matrix in echelon form. You know the echelon form? In 3 by 3, the first row, first column element should be non-zero, and at least the triangle shape of these three elements become 0. So it is the echelon form. So after writing the augmented matrix, the next step is to convert the augmented matrix in echelon form. Now we do some process. So it is not an equal matrix, it is equivalent matrix. So we put a equivalent symbol. Is a better, the first row, first column element should be 1. The simplification process is easy. You see, 9, 25, 1. We do only the row process because we need the number of non-zero rows. So if any chance the first element become 1, first we convert the element become 1, because the simplification process is 1. Now we see the first row and the third row. The first row element is 9, third row element is 1. Suppose we interchange these two rows, the 9 element become 1. So the first step, I interchange R1 and R3. 1, 1, 1, 9. And I don't change the second row. I write as it is second row. 25, 5, 1, 61. And I write the first row as the third row. 9 minus 3, 1, 21. We must write the process. Now we do in this matrix is R1 interchange R3. We interchange the first one and the third row. So first element is no problem, is 1, is 25 and 9. After changing this element is non-zero or 1, the next process is to convert this two element is first of all 0. So the next step, to convert this element become 0. 25, 1 and 25. How to change this element become a 0? Suppose we multiply the first row fully by the number same 25. I multiply the first row fully by the number 25. 25 minus 25 become 0. So the next step is, I don't change the first row, we write as it is. So 1, 1, 1, 9. And I write R2 as. This R2 as, our motive is to convert this element become a 0. So now I consider second row and the first row. Suppose I multiply the first row fully by the number 25. 25 minus 25 become 0. So how to write R2? We write R2 as R2 minus 25 times of R1. What is the reason to separate? Because both are the same sign. Okay, so we write the second row fully. Second row minus 25 times of the first row. So 25 minus 25 once are 25. 25 minus 25 is 0. How to change this element? The element 5. This element is 5, but we write R2 as R2 minus 25 R1. So 5 minus 25 into 1 is a 25. 5 minus 25. 5 minus 25 is minus 20. The number 1 become, okay, 5 minus 25 is minus 20. The number 1 become R2 minus 25 times of R1. So 1 minus 25. 1 minus 25 is minus 24. It's a big number. 61 and 9. We write R2 as R2 minus 25 R1. In the place of R2 here, 61 minus 25 times of the corresponding element of 61 in R1 is 9. So 61 minus 25 9 5 45 minus 4 is 18 is 225. So 225 we subtract 61. 5 minus 1 4. 12 minus 6 is 6 is 1. But the big number is a minus. So the answer is minus 164. So second row is work. Next we come in third row. What is the third row? This element, that element is 9. Our motive is to convert that element is also become 0. Now we consider in which rows is the easiest row. We consider R3 and R1 again. Suppose we can multiply the first row fully by the number 9. The first row, first element is also 9. Then we separate, that element is also become 0. So how to write R3? We write R3 as R3 minus 9 times of R1. So we write R3 as R3 minus 9 times of R1. 9 minus 9 times of 9. 9 minus 9 is 0. This element. Symbol also very important. Here minus 3. So I write as it is minus 3. Minus 9 of R3 value is minus 3. Minus 9 times of, okay, minus 9 times of the corresponding element is R1 is just 1. So what is the final answer? Minus 3 minus 9 is a minus 12. Okay. That element 1. Here also 1. But in R1 we multiply the number is 9. So 1 minus 9. 1 minus 9 is a minus 8. Is a big number. Is a 21. So we write 21. R3 value is 21. Minus 9 times of the corresponding element of 21 in R1 is 9. So 21 minus 81. 21 minus 81 is a minus 16. So now I subtract. The next motive is to convert at least this element becomes 0. But you see the second row and third row, any number is common. You see one number is common. First of all, minus is common in second row and third row fully. And also in second row, the number 4 is common in all the elements. We reduce, our simplification is easy. So I divide the second row fully by the number minus 1. Because all number involving minus. And you see the third row is also the number 4 is common. And also all the number having the minus sign. So I divide R3 also by minus 4. So don't change the first row. 1, 1, 1, 9. And I write R2 as R2 by minus 4. That is, I divide minus 4 fully by the second row. So 0 by minus 4 is 0. Minus 20 by minus 4. Minus by minus is a plus. 20 by 4 is a 5. 24 by 4. Minus by minus is plus. 24 by 4 is a 6. Minus by minus is plus. 164 by 4. Right? Minus 164 by minus 4. Minus by minus is plus. In fourth table, 16 is exactly 4 times. And 4 is 1 times. So the answer is 41. I write the third row is also divided by minus 4. R3 as R3 by minus 4. 0 by minus 4 is 0. Minus 12 by minus 4. Minus by minus is a plus. 12 by 4 is 3 times. Next, minus 8 by minus 4. Minus by minus is plus. 8 by 4 is 2. Next, minus 60 by minus 4. Minus by minus is plus. 60 by 4 is 15. For our easy convenience, the next step is I divide the second row and third row fully by the number minus 4. What is the next step? In echelon form, we do only one work. The remaining, the work is to convert that element is also become a 0. What element is? 3. After we change these two elements become a 0, we consider only the second row and the third row. So what is the working rule to convert that element become 0? You have any idea? Now we move, this element become 0. These two elements become 0. Next we see these two rows only. So the element is 3 and that element is 5. Our motive is to convert that element become a 0. So how to write R3? Suppose the number, both the numbers are different. So we do the interchange of the numbers. So we multiply third row fully by the number 5 and the second row fully by the number 3. It is a only working rule to convert that element become 0. So the first two rows is no change. We write as it is the first two rows. First row 1, 1, 1, 9. And second row 0, 5, 6, 41. And our motive is to convert that element become 0. So how to write R3? We write R3 as, we interchange the element. We write fully by the number R3 as 5 times of, we interchange the number 5 times of R3. Both have the same sign. So separate. Minus 5 times of R3. We interchange. 5 number is there. So minus 3 times of R2. We interchange the number 5 times of R3 and 3 times of R2. Both the numbers are 0. So we do any process, the value becomes 0. That element is also become 0. The element 3 become now 0 because we write R3 as 5R3. 5 3s are 15 minus 3R2. 3 5s are 15. Now the element 2 become. So I write briefly. We write R3 as 5R3. 5 times of the corresponding element of R3 is 2. So 5 into 2 minus 3 times of the corresponding element of 2 in R2 is 6. What is the final answer? 5 2s are 10 minus 3 6 are 18. 10 minus 18. 10 minus 18 is minus 8. 0. That value is minus 8. That element is already 0 and that element is minus 8. Now the last number. The second number is also 0. We already see because we interchange the element. That element is automatically 0. Now the number 15 become. Do you identify how to change the number 15? We write fully R3 as. We write fully the value of R3 as 5R3. 5 times of. The element of R3 is 15 minus 3 times of. The corresponding element of R2 is 41. So 5 15s are. Okay, 75. Minus, plus and minus is minus 3 into 41. 3 ones are 3, 3 fours are 12. 75 minus 123. 123, 75. 13 minus 5 is 8. We already take one borrow. So 11. 11 minus 7. 11 minus 7 is 4. Is 48. Is a plus 48 or minus 48? Is minus 48 because the big number is minus. So the answer is minus 48. What is the name of this matrix form? The name of this matrix form is in echelon form. The first row, first column element is non-zero, and at least the triangle shape of element become 0. So now we write it is in echelon form. It is in echelon form. What is the next step? You remember what is the next step? After we convert in echelon form in Gaussian elimination method, again we write the given system of matrix form into the equation form. That is to convert the matrix form into again the system of equations. 1, 1, 1. All are the coefficients of the sum is A, B, C, and RHS is the value of a constant. Okay, how to write the first row? All are involving 1. So 1 into A plus 1 into B plus 1 into C. It should be is equal to 9. Important, you don't put X, Y, Z. All the values are involving A, B, C. 1 into A is A plus B plus C is equal to 9. So we put it is equation 1. We use the equation, so I put it is equation 1. Now the second row. First one is 0. You know very well 0 into A is 0. Second one is the coefficient of B. I directly write. What is the element here? 5. 5B. Next one. 6. 6 is the coefficient of C plus 6C, whose corresponding element of RHS is 41. I use this equation also, so I put it is 2. Next, third row. First one is the coefficient of A, 0 to A is 0. Second one is the coefficient of B, 0 to B is 0. Third one is the coefficient of C, minus 8 into C is minus 8. Is equal to, whose corresponding element of RHS is minus 48. So the value of C is equal to minus 48 by minus 8. Minus 8 is equal to minus 48. So the value C is minus 48 by minus 8. Minus by minus is plus. In 8th table, 48 is exactly 6 times. 6 8s are 48. So we find the value of C. The value of C is 6. The next step, to substitute the value of C in equation 1 or 2, we substitute the value of C in first equation or the second equation. It is in second equation, because in second equation it contains only 2 unknowns. In first equation it contains 3 unknowns. So use the value of C in the second equation. So 2 gives. We will take the second equation. You see the second equation start from 5B plus 6C. So we write 5B plus 6. Now we use the value of C. 5B plus 6. C is the value of C is 6. What is the RHS of the second equation? 5B plus 6. We use the value of C. The value of C is also 6. Is equal to, the RHS of the second equation is 41. So we use the value of 41 here. 5B plus 6 6 36 is equal to 41. 5B is equal to 41 plus 36 become that side minus. 5B is equal to 41 minus 36 is a 5. Exactly we cancel. The value of B is plus 1. Next, we use the value of B and C in 1. Now we find the 2 unknowns B and C. The next step, to find the value of another unknown A. So now we use the value of B and C in 1. Now we go to equation 1. You see it is equation 1. The equation 1 contains A plus B plus C is equal to 9. Now we substitute the known values. So start from A. So first equation gives A plus B. The value of B is 1 plus C. The value of C is 6. is equal to 9. So A plus 7 is equal to 9. A is equal to 9 minus 7. The value of A is 2. So result. Our question is to find the values of A, B and C. The value of A is 2. The value of B is 1. And the value of C is 6. So in this sum, the value of A is 2, the value of B is 1 and the value of C is equal to 6. So it is a working rule to find the practical problem using Gaussian elimination method. What is the first step? To convert the given equation or 3 form. And next one, to convert the system of equation in matrix form. The next step, to write in augmented form. And then the next step, to convert it in echelon form. Again in echelon form, okay, it is in echelon form. Again we write the echelon form in the system of 3 equations. Then we have the unknown values of this A, B and C. Okay, the next question is also a word problem. You see the question. Last one, use a Gaussian elimination method to solve the problem using the same Gaussian elimination method. Okay, the concept of the question is, a boy is walking along the path, y is equal to ax square plus bx plus c. Through the points, there will be a 3 points is given. So a boy is walking along these 3 points. He wants to meet his friend. The friend is at a point p of 7, 60. Our question is, will he meet his friend? The boy will meet his friend. That is the question. Okay. No need the diagram. For understanding, I draw the diagram. Suppose a boy walking path is this. A boy is walking this path. It contains 3 points. Okay, the first 3 set of points. A boy is walking along this path. In this path, there will be 3 lines. Okay, through the points. The minus 6, 8 is second point and third point. The next one, our friend, is at a point p of 7, 60. Suppose the point 7, 60 is also lies in the same line. Suppose this is the point p of 7, 60. The boy should meet his friend because the point is also lies in the same line. Or suppose the point B is there, 7, 60. Okay, so it is a boy path and it is the location of his friend point. Suppose a friend is lies there, a boy does not meet. The point 7, 60 is also lies in the same path. A boy must meet his friend. It is the concept of the question. Okay. So the first step, using the given data to find the unknown values A, B and C. Okay, it is y is equal to ax square plus bx plus c is a quadratic equation. So in this quadratic equation, first we find the constants A, B and C. So there will be 3 clues are there. You know very well, any one point is lies any one of the line. The point must satisfy the equation. That is, in this equation, we replace x by the first point and y by the second point. So using these 3 points to find the constants A, B and C. So we have one quadratic equation. So in this quadratic equation, we substitute the value of 7, 60. Suppose the point 7, 60 satisfies this equation. That point is also lies in the equation. Therefore, the boy must meet his friend. Suppose the point 7, 60 does not satisfy the given equation. The boy does not meet his friend. So it is the concept of the given question. So now is the diagram. So it is for your understanding. So a boy is walking along this way. There will be 3 points. What is the name of this equation? Y is equal to ax square plus bx plus c. Using these 3 points to find the unknown constants A, B and C. Next, in this equation, we replace x by 7 and y by 60. The equation is satisfied. We come to the conclusion the point is also lies in the same line, therefore the boy mate is a friend. So it is the constant of the question. First one we will take the given equation. Okay, the given equation is given y is equal to ax square plus bx plus c. I use this equation, so I put it is equation 1. Next says it passing through is passing through the point minus 6 comma 8. So any one of the point is passing through any one of the line, the point must satisfies the equation. Satisfies the equation means we replace x by the first point and y by the second one. So since this point is passing through that line, so we replace x by minus 6 and y by 8. So 1 gives 8. The value y is 8 is equal to a of x square. The value of x is minus 6. Minus 6 the whole square plus bx. b of x value is minus 6 plus c. So 8. a of minus 6 the whole square is 36. Plus and minus is minus 6b plus c. You know very well a into 36 is 36a. So how to write this equation? 36a minus 6b plus c is equal to 8. So 36a minus 6b plus c is equal to 8. Now we form the first equation of the given data using the same manner to frame the another two equations. Now we frame the first equation. Now we come to the second point. This curve is also passing through the second point minus 2 comma minus 12. How to write? Now the curve passing through the second point is minus 2 comma minus 12. The curve is also passing through the second point minus 2 comma minus 12. So in the first equation, now we replace x by first point is minus 2 and y by minus 2. So 1 gives y, the value y is LHS is y, the value y is minus 12 is equal to a of x square. A of the value of x is minus 2 the whole square plus b of x, b of minus 2 plus c. Because that point is passing through the given equation, so the point is satisfies the equation. Satisfies the equation means in the first equation whenever x is there we replace x by minus 2. Whenever y is there we replace y by minus 12 we replace. So minus 12 is equal to a of minus 2 the whole square is 4. Plus and minus is minus 2b plus c. So we write it is 4a. a into 4. 4a minus 2b plus c is equal to minus 12. Now we frame the second equation. Also the given curve passing through the one more point. Also the curve passing through the third point. The third point is 3 comma 8. So we replace x by 3 and y by 8 in the given equation. 1. LHS is y. The value of y is 8. A x square. A. The value of x is 3. 3 square. Plus bx. B into 3. Plus c. So 8 is equal to Yeah, of the value of 3 square is 9. 3b plus c, so 9a plus 3b plus c is equal to 8. So it is the first step, using the given data to form a 3 equations. The given curve is passing through the 3 points. So using these 3 points, we created 3 equations. The next step, to convert the given system of equation in a matrix form. Okay, to convert in matrix form. So we take the first, second and third equation. Actually it is the third equation. Now using the first, second and third equation, we will take one matrix form. The first one matrix is always the coefficients of ABC. And second one is the values of A, B, C. Is equal to the RHS is the constant matrix. You remember the equation 1? The equation 1, the coefficient of A, B, C are. In equation 1, the coefficient A, B, C are 36, minus 6, 1. Coefficient of A is 36, B is minus 6, and C is 1. And the RHS of the first equation. The RHS of the first equation is 8. So we write here 8. First equation over. Usually we will be taking it is a value of A, B, C. It's important, it's not X, Y, Z, because all the 3 equations involving the coefficient of A, B, C. So A, B, C. First equation coefficient of A 36, B minus 6, C is 1, and corresponding RHS of the first equation is 8. Now we move to the second equation. In second equation, the coefficient of ABC the second equation coefficient ABC are 4 minus 2, 1. And the RHS of the second equation is minus 12. Wow. Our third equation is the coefficient of A is 9, B 3, coefficient of C is 1. And the RHS of the third equation is 8. Now it is of the form AX is equal to B. It is a matrix A, it is a matrix X, and RHS is a matrix B. After we converted in matrix form, the next step is to write the augmented matrix. Augmented means extended. The matrix A is extended by the matrix B. So the next step, the augmented matrix is the symbol of the augmented matrix A, B, A line B. That is, the matrix A is extended by another matrix B. Now what is the values of the matrix A? 36 minus 6, 1. 36 minus 6, 1. Second row, 4 minus 2, 1. Third row, 9, 3, 1. It should be extended by, okay, it should be extended by the another matrix is B. The value of B, 8 minus 12, 8. 8 minus 12, 8. So, echelon form, augmented matrix is over. The next step, to convert this matrix in echelon form. After we write the augmented matrix, the next step to convert this matrix in echelon form. You know the echelon form, the first row, first column element is also 1, but it is 36. We do only the row process, we don't change the column. But in second row and third row also, there is no number involving 1. So in this sum, 1 is impossible. So it's a better to convert the easy number or a smallest number in the first row. 36, 4 and 9. Which is a small number? 4 is a small number. So the first step, this number 4 goes into the first row. So now I interchange first row and the second row. So 4 minus 2, 1 minus 2. I interchange the first row and second row. So I write the second row fully by the first row and the first row fully by the second row. 36 minus 6, 1, 8. We do the process. R1 interchange R2. R1 gives R2 and R2 gives R1. Third row as it is 9, 3, 1, 8. So is the first step. So in this sum, there is no way to convert the number 4 become 1. So in some of the sums, the one is impossible, no problem. The one, this number is always a non-zero. It is easy to convert in echelon form, the number is become 1. But in this sum, there is no way to convert it, it is in 1. There is a way, we divide to R1 fully by the number 4. But some fractions occur here. So I leave 4 as it is. So first row is no problem, it's a non-zero. The next step, to convert these two elements become 0. So the next step is to convert this element 36 become a 0. What is the process? There will be two ways. We consider R2 and R3, or R2 and R1, because 36. 4 9s are 36, or 9 4s are 36. Is your choice. I will take R1 and R2. Okay, 36. Suppose that number is also become a 36. When we separate, that element become 0. There is a chance. So I consider the second row and the first row. So first row is no change. I write the first row as it is. 4 minus 2, 1 minus 12. And I write R2 as. Okay. Now the motive is to convert that element become 0. I consider R2 and R1. 36, 4 is there. Suppose I multiply fully by the first row by the number 9. 9 4s are 36. So we write R2 as R2 minus 9 times of R1. Okay, 9 times of R1. 36 minus 9 4s are 36. 36 minus 36 is 0. The next one is also important. Here the corresponding element is here minus 6. So minus 6 minus 9 times of whose corresponding element of R1 is minus 2. Minus 6 minus minus is plus 9 2s are 18. Minus 6 plus 18. Minus 6 plus 18 is a plus 12. The sign also very important. Next, the number 1 become, we write R2 as R2 minus 9 times of R1. So 1 minus 9. 1 minus 9 is a minus 8. Next one, the number 8 becomes 8 minus 12. It's a big number. If I do inside one, R2 is 8 minus 9 times of the corresponding element of R1 is minus 12. Minus 12. So 8. This minus and minus is plus. Minus and minus is plus. 9 2s are 18, 8. Remainder is 1 is 10. 108 plus 8. 108 plus 8 is 116. 116. So the second row, our motive is to convert the first element becomes 0. So okay. The next step, to convert that element is also become 0. This element is also become 0. So we will take R3 as R3, R2 or R1 is your choice. But it is easy, we will consider the second row and third row. Because 36 and 9 having one common table. So to convert this element becomes 0, I consider the third row and the second row. So how to write that third row? Now the second row fully over. Now we come in R3. R3 as. Our motive is to convert that element become 0. I consider R3 and R2. 9 4s are 36. Same sign, so we separate. So how to write R3? We write R3 as 4 times of R3, that is 4 9s are 36. Already 36 is there. So we write R3 as 4 R3 minus R2. 4 times of R3 minus R2. 4 nines are 36 minus 36. 36 minus 36 is 0. First element is no problem, it's always 0. The number 3 become, the number 3. We write R3 as 4 into 3. 4 times of R3 minus R2 minus, the corresponding element of R2 is minus 6. You see 4 3s are 12. Minus and minus is plus 6. 12 plus 6 is 18. 12 plus 6 is 18. So this number is wrong. Now that number 1, 4 or 3. 4 ones are 4 minus 1. 4 minus 1 is 3. This is the number. Now both are 8. But R3 is multiplied by the number 4. We write R3 as 4 R3. So 4 times of R3 is 8. So 4 into 8 minus 8. 4 8s are 32 minus 8. 32 minus 8 is 24. So to convert in equivalent form, first we check the first row, first element is a non-zero. Next we convert these two elements become a 0. And the next one step is the step is to convert that element is also become 0. So it's a process. But you see the numbers are some big number. 24, 116, 18, 12. So to reduce. You know, in a row, any one number is common, we divide. You see any number is common in the second row? Yes, one number is there. The number is 12, 8, 116. All are having in the fourth table. So we divide R2 fully by the number 4. And that row also one number is common. You identify? The number is 3, 18, 3, 24. So first row is no change. 4 minus 2, 1 minus 12. Don't change the first row. I write the second row as R2 as R2 by plus 4 or minus 4. Only one number contains a minus. So it's divided by 4 1. I write R2 as R2 by 4. That is row 2 fully divided by the number 4. 0 by 4, 0. 12 by 4, 12 by 4 is a 3. Minus 8 by 4, minus 8 by 4, minus 2. 116 by 4, 116 by 4. In fourth table, 11 is 2 times. 2 4s are 8. Remaining 3, 36. In fourth table, 36 is 9 times. So 29. And I write R3 also. Okay, R3 is a common number 3. So divide by 3. R3 by 3. 0. 18 by 3. Is 18 by 3 is 6. 3 by 3, 1. 24 by 3. 24 by 3 is 8. The next, we have only one work. The work is to convert that element is also become 0. The next step, to convert that element is become 0. Okay, so don't change the first row and second row. So we write the first two rows is as it is. First row, 4 minus 1, minus 2, 1. 4 minus 2, 1. No change in the first row, minus 2. And the second row also, we write same. The second row, 0, 3, minus 2, 29. 0, 3, 2, minus 2, 0, 3, minus 2, 29. Our motive is to convert that element becomes 0. We already tell. After we convert this two element becomes 0, we consider only the second row and third row. 6, 3. Do you have an idea? The number is 6, 3. Suppose that element is also become a 6. 6 minus 6 become 0. So we write R3 as R3 minus 2 times of R2. So the number 3 is also become 6. 6 minus 6 is 0. So now we write this R3 as R3 minus 2 times of R2. We write R3 as R3 minus 2 times of R2. This element is no problem. All the numbers are 0. We write R3 as R3 minus 2 R2 because 6, 3 is there. So we write R3 fully by R3 minus 2 times of R2. So the first number is no problem because both numbers are 0. So that element is always 0. And the second element is also 0 because 6 minus 2 3s are 6. 6 minus 6 is 0. Next, the number 1 become 1 minus 2 whose corresponding element is R2 is minus 2. Now we write R3 as R3 minus 2 R2. R3 1 minus 2 times half the corresponding element of R2 is minus 2. What is the final number? 1 minus minus is plus 2 to 4. 1 plus 4 is 5. Next, the next number is 8. Here 29. We write R3 as R3. The value of R3 is 8 minus 2 times of R2. The corresponding element of 8 in R2 is 29. 8 plus and minus is minus 2 into 29. 2 9s are 88. Remember 1 58. 8 minus 58 is a minus 50. Now you see it is in echelon form. That form is called an echelon form because the first one is a non-zero element and at least this triangle shape of element become 0. So now it is in echelon form. Now we write it is in echelon form. What is the next step? We write this matrix form as a system of equations. This one all are the coefficients of A, B, C. And the line above all the numbers are involving the constants. So we write first one is the coefficient of A. So 4A. Second one is the coefficient of B is a minus 2. So I write minus 2B. And third one is the coefficient of C. Plus 1 into C is C. Is equal to minus 12. We use the equation, so I put it as equation 2. In the previous starting, we put the given equation as a first equation, so I put it as equation 2. Next, how to write the second row? This one is the coefficient of A is 0. 0 to A is 0. This one is the coefficient of B. 3 into B is 3B. This is the coefficient of C. Minus 2 into C minus 2C is equal to RHS constant is 29. Third equation. And the last one. 0 into A 0. 0 into B 0. Plus 5 into C is 5C. Is equal to whose corresponding element in RHS is minus 50. I cancel in 50 table. The value of C is minus 10. Okay, cancel in 50 table. The value C is minus 10. Now we use the value of C in 3. Because in 2, it contains 3 unknowns. In 3, it contains 2 unknowns. We use the value of C in 3. So third equation become 3 gives. Start from 3B. 3B minus 2 into C. The value C is minus 10. Is equal to RHS is 29. RHS is 29. So 3B minus and minus is a plus. 2 times are 20. Is equal to 29. 3B is equal to 29 minus 20 So 3b is equal to 29 minus 20. 29 minus 20 is 9. So 3b is equal to 9. I cancel in the third table. The value of b is equal to 3. Next, we use the value of c and b in 2. So 2 gives, start from 4a. 4a minus 2b. Minus 2. The value b is 3. Minus 2 into 3. Plus c. The value c is minus 10. Actually plus is the minus 10. Is equal to RHS is minus 12. I use the value of a, b and c in 1. 4a minus 2 3s are 6. Plus into minus is minus 10 is equal to minus 12. 4a minus 6 minus 10 is a minus 16 is equal to minus 12. Minus 16 goes to RHS, it becomes plus 16. 4a is equal to minus 16 becomes, let's say, plus 16. Already the RHS is minus 12. So 4a is equal to 4. We cancel. The value of a is equal to 1. Now we find the constants a, b, c. It's not a confusion. Our question is not to find a, b, c. Now we use the value of a, b, c in the first equation. Okay, you remember the first equation? The first equation is y is equal to ax square plus bx plus c. So y is equal to a. The value of a is 1. 1 into x square plus b. The value of b is 3. So 3 into x plus c. The value of c is minus 10. So plus into minus 10. So y is equal to x square plus 3 into x is 3x. Plus into minus is minus 10. Actually, this is the equation of the path. The boy is path y is equal to x square plus 3x minus 10. This also is not a verified answer. Now to check, the front is along this path or the front is go other any other path. The next step, the point P of the 7, 10 is satisfies this equation or not. Actually, this is the equation of the path of the boy. Okay, we find the value of a, b, c. The next step, to check whose front point is also lies in this line. Suppose the point is satisfies this equation, the front is also lies in the along the path of the boy. So we come to the conclusion, a boy is meet with this front. Suppose the point does not satisfy this equation, the boy does not meet his friend. This is the required equation. Actually, this equation is a path of the boy. Next, to check the front point is also lies in this equation. Actually, the front point is P of 7, 60. The point is suppose satisfies this equation, we come to the conclusion whose front is also lies in the same line or same path, so both are meeting. Suppose the point does not satisfy this equation, the front is going the another path, so both does not meet. So the next step, to check this point satisfies this equation or not. Satisfies means both LHS and RHS both are equal or not. So always the first one is a value of x. So we put x is equal to 7 and y is equal to 60 in this equation. So the value of y is 60 is equal to x square. The value of x is 7 plus 3 into x. 3 of the value of x is 7 minus 10. 60 is equal to 7 square 49 plus 3 7s are 21 minus 10. 60 is equal to 49 plus 21 is 70. 9 plus 1 10, remainder of 5 7 minus 10. So 60 is equal to 60. So the point is satisfies this equation. Therefore, the point P of 7,60 satisfies the given equation. It's important, it satisfies the given equation. Therefore, the boy will meet is a friend. Is the question. The boy will meet or does not meet. The friend point is also lies in the same way of the boy. The point is satisfies the given equation. Therefore, the boy must meet his friend.